Question 5, we have masses of 5 and 3. 5 and 3. What have we got going on before and after? We have opposite directions, so we're going to have plus and a minus here for our speeds. Before there's 6 and 4, so we're going to have 6i and 4i. And the coefficient of restitution, we're told, is a third. We know, so putting two simultaneous equations in P and Q will enable us to get the speeds afterwards, which is what they're going to look for. Then the loss in kinetic energy and the change in momentum. So similar types of questions again. So V1 minus V2 over U1 minus U2 is equal to minus E. So we're going to get P minus Q over 6 minus minus 4, 6 plus 4. It's going to be equal to minus 1 over 3. So we're going to get 3P minus 3Q is equal to minus 10. Putting this information into M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. We're going to get 5 by 6 plus 3 by minus 4 is equal to 5 times P plus 3 times Q. So we're going to get 5P plus 3Q is equal to 30 minus 12, which is 18. We have a plus 3Q and a minus 3Q. So we're going to get 3P minus 3Q equals minus 10. So we're going to get 8P is equal to 8. So P is equal to 1. If P is equal to 1, we're going to get 3 minus 3Q is equal to minus 10. So we're going to get 3Q. If we bring it to the right and bring the 10 to the left, it'll be positive, so 13. So Q is equal to 13 over 3. So the loss of kinetic energy due to the collision suffered by the 5 kilo sphere. So just the 5 kilo sphere. Loss of kinetic energy. So half mu squared. So we have a half times the mass of 5 kilo, 5. So by u squared, so it started at 6 and it ended at P, which was 1. So we have a half 5 by 6 squared, and we have a half 5 by 1 squared. So that's 2.5 times 36, which is 72 and 18, which is 90. And a half of 5, just 2.5. So it was 90. It ended up at 2.5. So it lost 87.5 joules of energy. And the last part, the change in the momentum or the impulse on the 3 kilo. So the change in momentum, mv, what did it end up at? Minus what it started at. So the 3 kilo is 3 times minus 3 times. So what were its speeds? So it was minus 4 at the beginning, and it ended up at 13 over 3. 13 over 3 minus 4. So we're going to get 13 plus 12, which is equal to 25 I Newton seconds for its impulse. Question 6, we have a mass of 2 moving at 10, colliding directly, so same signs with a stationary sphere. Okay, so we have masses. We have one at rest, and we have one traveling at speed. So the masses are 2 and 3. 2 and 3 before and after. The 2 is traveling at 10, and B is at rest, so that's 0. And we're given E is a half, and we want the speed of each sphere. So we have our pi and our qj, or qi, pi and qi. Form your simultaneous equations with v1 minus v2 over u1 minus u2 equals minus e. So that's our p minus q over 10 minus 0 is equal to minus 1 over 2. 2p minus 2q is equal to minus 10. Then we have m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. So we're going to have 2 by 10 plus 3 by 0 is equal to 2p plus 3q. So we're going to get 2p plus 3q is equal to 20. And we have 2p in both, so I'm going to just multiply this one by minus 1 and bring it across. So minus 2p plus 2q is equal to plus 10. So I'm going to get 5q equals 30. So q has to be equal to 6. And if q is equal to 6, I have 2p minus 12 is equal to minus 10. 2p is equal to 12 minus 10, 2. So p therefore will be 1. So we have the speeds afterwards of 1i and 6i. Part 2, loss in kinetic energy. So we're half mu squared. So at the beginning of half, the 2 and the 10, mu squared, and the other one's going to give 0, but we'll put it in anyway just to show the half 3 by 0 squared. So a half and the 2 cancel, so we're just going to get 100 joules here. That's what's going on beforehand. And then afterwards we have a half times 2 times p squared, which is just 1 squared. And we have a half times 3 times q squared, which is 6 squared. So again, we're just going to have 1 plus, we're going to have 36. 1.5 times 36 is 36 and 18, which is 54. So we're going to have 55 joules afterwards. The loss, 100 minus 55 is 45 joules. And then the power exerted by an agent which brings B to rest again after 2 seconds. So we're looking for force here. What force is at play here? Force is equal to ma. So we're going to need to build up to this a little bit, I think. So for B, what do we have? We speed of 6, this Q. So speed is 6. It's coming to rest in a certain amount of time. What do we say? Once 2 seconds, you can see it there. So we can definitely get the acceleration here. VU AT. So V is equal to U plus AT. So we're going to have 0, 6 plus 2A. So A is going to be equal to minus 3 here. We can see it's slowing down. So the force at play, force is equal to mass times acceleration. So the force at play and bringing it to rest is going to be its mass. Just remind myself what its mass was. 3. Mass was 3 by minus 3. So that's going to be a force of minus 9 newtons, or a resistance force, if you want to call it a resistance force. Just going to bring it to rest. Anything else going on here? Well, we're told it went 6 meters. Was it? No, the distance traveled. We could get the distance traveled. If it starts at 6 and it comes to rest in 2 seconds, and the acceleration is minus 3, S is equal to UT plus a half AT squared. How far does it travel? S is equal to 6 times 2 plus a half times minus 3 times 2 squared, which is 4. So the distance traveled is going to be 12, and it's going to be minus 6. So the distance traveled is 6 meters. What else could I throw in for this question? The work done, force by distance, the minus 9, or we call it 9. The force 9 and the distance 6. work is measured in joules. The work done is 54 joules, and we go to wattage then, don't we? Power is equal to the work done over the time taken. 54 over the 2 seconds, so power measured in watts is 27 watts. We could add a couple of little additions to these questions for Leaving Cert 2022.